Welcome to this lecture where we provide an introduction to multi-access solutions that are today becoming prevalent over the internet. My name is Anna Brunström, professor in computer science at Karlstad University. So in this lecture, we will look at the what, the why, and the how. What is multi-access and how does it differ from single-access communication? Why would we like to use multi-access solutions? What are the use cases where multi-access solutions are beneficial? And how can we realize multi-access? How it is supported at different layers in the network stack, and a brief introduction to multipath TCP. So let's start with the what. So traditionally, internet-based services communicate over a single network path. So in the example in the slide, we, for instance, have a client connected to the internet using a Wi-Fi connection, communicating over a single path to the server. And this is a normal setup that we may be used to. Today, of course, however, most of our devices that we use have multiple network interfaces available. If you think about your mobile phone, for instance, your mobile phone will have both a Wi-Fi connection and a cellular connection. So it's actually possible for us today to communicate over multiple paths. So in the example in the slide, we see that the connection from the client has a connection both over Wi-Fi and over 5G. We have multiple paths throughout some portion of our connection, and then maybe again towards the server we have a single path. But our devices today, our user devices, are typically multi-homed, and we can take advantage of that by communicating over multiple paths. So why would we like to use multi-access solutions? What can it bring us? Well, the typical use of multi-access has been to provide more ubiquitous internet access. So if we have both Wi-Fi and cellular available, sometimes we may have coverage over Wi-Fi, but not in cellular. In other places, maybe only cellular coverage is available. By combining these two interfaces, we can make sure that we have a good connection at a more frequent time. Using the multiple interfaces in a good way can also provide us more cheap internet access. So typically, Wi-Fi is a less costly connection than the cellular. Over cellular, we may have a cost for the bytes that we transfer, but we may have some free Wi-Fi hotspots available, for instance. So here, we can use Wi-Fi to get a cheaper internet access. We may also use the multiple interfaces to provide a better performance. So often maybe Wi-Fi gives a better performance, a higher throughput, a lower delay than our cellular connection. So these are some ways of selecting one of the available interfaces to increase our coverage, our costs, or the performance. However, the choice of Wi-Fi over cellular is perhaps today not always the best choice. So sometimes our cellular network connection is faster and more stable than our Wi-Fi connection. But if we have two connections available, two possibility to communicate over two interfaces, why only use one of them at a time? We may also use both of them simultaneously in different ways. And this is what the multi-access solutions provide. And why would we then want to do that? Well, potentially, maybe we can get a much better performance this way. We may be able to aggregate communicating over multiple network paths. So if we send data over multiple paths in this simple example in the slide, we have two connections available, one providing 100 megabit per second throughput and another one a 50 megabit per second throughput through the client. So if we combine these two connections, we may achieve 150 megabit per second throughput. So this may be the first thing that you think about if we say use the multiple paths that we can aggregate and we can get a larger throughput. But we also have many other very important use cases for the multi-access. And one of them is to more seamlessly support user mobility. So if we move in and out of coverage between different networks, if we can have the different connections up simultaneously, we don't have to restart our connections and have perhaps an interruption in the communication. And this is similar to also the resilience to link failures. So this may happen both in the mobile scenario, but also in stationary scenarios. Maybe one of our links fail, and then it's beneficial if we have a backup link that we can also use for the communication. Or if we are communicating over both paths simultaneously and one of them goes down, our connectivity should stay up, but maybe we just have the ability to transfer less data. Another use case that is also an important use case for multi-access is in data center networks, where you often have multiple paths available between two hosts in the network. And here you can also use the multiple paths to increase your performance. So if multi-access is now beneficial, how can we actually get it? Well, in principle, what you need is an application or a protocol that supports it. And this support may be available at different levels in the protocol stack, and this have different pros and cons. So you may have the support directly in the application. So applications like XFTP or Grid FTP, for example, use multiple TCP connections to improve the performance of FTP. Another example is multi-TCP, which uses multiple TCP connections for multimedia streaming. So here each application provides the multi-access or the multi-path support. Another option is to implement it in the transport layer, making this service available to all the applications that run on top. And this is the approach if we use, for instance, multipath TCP. Or we also have the Stream Control Transmission Protocol, SCTP, which supports multi-homing. And the emerging QUIC protocol, it also envisioned to have multipath support in the future. You may also support multi-access at the network layer. Here again, there are multiple approaches. You may, for instance, use identity locator split approaches, like in the host identity protocol HIP, which has multi-homing support for failovers. And MHIP then adds multipath support for also aggregating and using multiple connections simultaneously. Another approach is proxy-based approaches, such as PRISM, where you may, for instance, have an IP encapsulation between 2 points in the network. You may also use multi-access at the link layer, at the physical layer, for instance, through link bonding. So what are then the pros and cons of providing multi-access support at different communication layers? Well, if we start to look at the application layer, integrating multi-access support in the applications gives you a lot of flexibility. You have a lot of knowledge about your application and you can steer your traffic according to this. But it may also lead to more complex applications. And it means that each application has to implement this support individually. It may also mean that your application is not portable across devices, or that it cannot be used in the same way across use cases. So another approach is to implement the functionality at the transport layer. Now this support can be transparent to the user and the application, even if you may also want to have some interface to provide some guidance. So in this case, the transport layer is the layer that is responsible for transmission of the data and determining how to send the different data segments over the available paths. One issue with the multipath support at the transport layer is that then, of course, each of the endpoints needs to support it, and it must also be possible to pass this traffic through the network so that you don't have any middle boxes that interfere with the communication if you, for instance, want to extend an existing protocol or bring in a new protocol. You may also have the support at the network layer. Again, this is transparent to the end host users, and it can also possibly leverage completely in-network solutions. But if you now transfer packets over multiple paths in the network without having a knowledge of how these packets relates to your applications or how the flows relates to your application, you may have problems with packet reordering. That can cause problems both for the transport layer or for your application. And finally, you may work at the data link or physical layer. Here it is maybe more easy to handle the reordering issue because your rate is stable and you can schedule your traffic and ensure that your link delivers your packets still in order. But of course, this only works on a point-to-point basis over a single link. So in this course, we will focus for the remainder of our discussions on the transport protocols and providing multi-access solutions at the transport layer, using, for example, multipath TCP or MPTCP. So we will talk more about the details of these protocols in coming lectures, but let me just give a short introduction to how we can realize multi-access using MPTCP. So MPTCP reuses TCP to implement multipath support. And multipath TCP is defined in the RFC 6824. We are now in the process of getting an update to the protocol with some enhancements and smaller modifications, but the basic principle is will still remain the same also in the updated specification. And MPTCP provides a set of extensions to TCP that allows it to communicate over multiple paths. You can see it as adding a meta layer on top of several underlying TCP connections. So it allows multiple subflows or using multiple TCP connections for one MPTCP connection. And typically you may have one subflow or use one underlying TCP connection per network interface. And MPTCP is today being used in commercial applications and by well-known vendors. So if you, for instance, have an iPhone, you have MPTCP support and maybe you are not aware of it, but if you use a service like Siri, you will have this supported over multiple interfaces over both Wi-Fi and cellular. So to summarize this introduction, multi-access is motivated by an increasing availability of multiple interfaces in our user terminals and in our devices. And multi-access can provide a number of benefits over single access. So it can provide an increased robustness because if one link fails, another link is available and your communication can still continue without interruption. It can support mobility because if you move in and out between different networks and you have a multipath or multi-access capable application or protocol, you can do this seamlessly and with much less interruptions at least. And finally, you may also be able to increase your performance by aggregating and communicating, sending data over multiple paths simultaneously. And as we have seen in the lecture, multi-access solutions can be realized at different layers in the communication stack. And these also have different pros and cons depending on where you realize your solution.